In this video, we're going to factorise the quadratic 4x squared minus 2x minus 5 using the completing the square method. So the first thing we have to do is make sure that the coefficient out the front of x squared is equal to 1. So in this case, the coefficient of x squared is actually 4. So what we're going to do is we're going to divide every term in the expression by 4 and remove it as the highest common factor. So we're going to be able to write 4 outside of, and what's going to be left is x squared minus a half x minus 5 on 4. So now that we've removed the 4, we've now got the x squared term with the 1 out the front. Even though the 4 is technically still affecting it, we've managed to remove it so that we can now complete the square on the remaining terms. So step 1 gets us to look at the coefficient of the x term. So the coefficient of the x term is the negative a half. So we have negative a half, and what we're going to do is we're going to divide that by 2, which is the same as saying we're going to have negative a half times by 1/2. So all up, that's going to give us negative a quarter. And then we're going to have negative a quarter all squared, because we halve and square the term in front of the x. And just as a review, that's the same as negative 1 on 4 times negative 1 on 4, which gives positive 1 on 16. So in step 2, and we'll do 3 at the same time, we've still got the 4 out the front of our expression. And in there, we're going to have x squared minus a half x. Then we're going to add on 1 on 16, subtract off the same to maintain the expression, and then we've still got minus 5 on 4. So all we need to do is clean this up a little bit. So the first thing we need to note is that the first 3 terms inside the bracket are in fact a perfect square. So step 4 gets us to factorise those first few terms as a perfect square. So we're going to have 4 outside of, and the perfect square is going to be x minus 1 on 4 all squared, where the minus 1 on 4 comes from this half b term up here. Then of course we've still got minus 1 on 16 minus 5 on 4. And we've now factorised part of the expression as a perfect square. So over here, we're going to go through step 5. So step 5 is to clean up the remaining terms. So the first thing we need to note is that the negative 5 on 4, so if we have a look, the negative 5 on 4 just up here can be written as negative 20 on 16, so that we've got a common factor to add these 2 terms down the bottom together. So now that we know that, we can rewrite our expression as x minus 1 on 4 all squared minus minus 1 on 16 minus 20 on 16. And then combining those, we can have 4 outside of x minus 1 on 4 all squared minus 21 on 16. And now the last thing we need to do is make sure that we distribute the 4 back into all the terms inside the big red brackets. So when we do that, we get that we have 4 times x minus 1 on 4 all squared minus 4 times 21 on 16. So when we do this, we've still got 4 outside of x minus 1 on 4 all squared, and then minus 4 times 21 on 16 will give minus 21 on 4. So with that in mind, we can state that the turning point for this parabola occurs at x, y is equal to positive 1 on 4, negative 21 on 4.